Jump right in. Question number 1. This is a distributive property problem. All we have to do is distribute the multiplication of 5 into each of these three terms. I mean, technically, you're supposed to look at the parentheses, and on the inside it's telling you to add x plus y, which you can't, or y plus 3, which you can't, right? You could only combine those like terms. Like if you had an x plus x, then you'd be able to combine them. So you can't do that. All we need to do is distribute the multiplication of 5. I always like to draw a circle and then an arrow. 5 times x is 5x. 5 times positive y is a positive 5y. And 5 times positive 3 is a positive 15. And ladies and gentlemen, this is our answer, 5x plus 5y plus 15. Nice and simple. Next question, number 2. Here we go. Again, we are distributing, again, because if you look at the inside, it says negative 4x minus 9y. You cannot combine terms that are not alike. If this said negative 4x minus 9x, then you would be able to combine them and get a negative 13x, but you can't do that. These are not like terms. Anyways, so we're going to move on to the outside of the parentheses. There's a multiplication right there. We're going to distribute that multiplication of negative 10. Negative 10 times negative 4x, that is a positive 40x. And negative 10 times negative 9y, that is a positive, right? Because a negative times a negative equals a positive 90. And of course, we have a y on that one. And it's that easy. That's your answer, 40x plus 90y. Moving on to a order of operations question, right? We need to just simplify this. And of course, we have three operations here: division, multiplication, and subtraction. So of course, when it comes to PEMDAS, that's our order of operations. First parentheses, then exponents, and then multiplication or division. Notice that they're both blue because you don't have to multiply first before dividing. You don't have to multiply, or you don't have to divide before multiplying. Whenever you're faced with both multiplication and division, go from left to right. Same thing with addition or subtraction. Anyways, I bring that up because we have division here and multiplication there. A lot of students see the M come first on PEMDAS and they want to multiply first. That's incorrect. What you need to do is go from left to right when you're faced with multiplication and division. Okay, so first we're going to begin with 75 divided by 5. That is 15. And then of course we're simply going to bring down the multiplication of 7 and then the subtraction of 7. So times 7 minus 7. Now question is, what is 15 times 7? Use a calculator. I just used the calculator to find out that that's 105. Okay, so we have 105 and then bring down the minus 7, and that answer is 98. And again, this is just an order of operations problem, right? First division, then multiplication, because you go from left to right, and then subtraction at the very end. Moving on. Another order of operations question. Again, PEMDAS is what it's all about. You first look for parentheses, which we have right here. And 7 plus 49, that is 56. So if you want, you could keep the parentheses and just put 56 right there, because after all, that's what parentheses tell you to do. They tell you to ignore everything on the outside and just zoom in and do what's on the inside. That's 56. Now I'm going to bring everything else down. Okay, so the division of 2 comes down and the subtraction and the 13 comes down. So now, even though we still left the parentheses there, they're not really necessary because there's nothing to multiply out here. This is really just saying 56 divided by 2. Okay, and that's the next thing we do. Or let's go through all the steps here, or all the things you're supposed to check. First, parentheses. We did that. 7 plus 49 is 56. E, do we have any exponents? No, we don't have like a power of 2 or a power of 3, so no exponents. Moving on to multiplication or division. There is division. That's what we're going to do next. So 56 divided by 2, half of 56 would be 28. So we have 28, and let's bring down the minus 13. And after that, we will be done. 28 take away 13 is 15. So your answer there is 15. Finally, we have a question that doesn't really involve any math. It's just, do you know what a function is? Or if it's just a relation, or in this case, is it a function or is it not a function? There's only two options here. It's like a 50-50 shot, even if you don't know. But the bottom line is, in a function's like a machine. For each input, there's exactly one output. All right, that's what you got to remember. And I always say it's kind of like a machine, right? Like you put in some, like imagine there's a machine Let me just draw a quick little box right here, okay? And let's say inside this box, in here, let's say in here goes the dough, all right? And out here comes the donut. Okay, so you put in some dough, it comes out a donut. Put in some dough, comes out a donut. Imagine if you put in some dough and then all of a sudden it comes out a tortilla. That means that the machine's broken. All right, that input is, if you plug in any input, it's supposed to give you the same output every time you do it. So what this is saying is I plug in a -4, I get out a -1. I plug in a -2, I get out a 4. I plug in a 0, I get out a -1. I plug in a 2, I get out a 1. I plug in a 4, I get out a 4. Never do I plug in the same number twice and get out different answers, okay? So this is a function, okay? For each input, there is exactly one output. Now, if for some reason you plug in, let's say you plug in the 4 and it gives you a 4, but then you plug in the 4 again and it gives you a 5, then that would no longer be a function. That machine is broken. So you would say not a function if that were the case, but obviously that's not the case. Let me erase it, okay? So right here for each input, there's exactly one output, okay? That's what it says. For each input, there's exactly one output. And as you could see, plug in a 4. Do you get out 2 different answers? No, you just get out one answer. Plug in a 2, you just get out one answer. Plug in a -2, just get out one answer. So this is a perfectly fine function, okay? So that is your answer here, function. Let's compare that to another one. On this one right here, it says, is this mapping a function or not a function? So again, for each input, there's one output. So when you plug in a 1, how many answers do you get? It gives you the answer 5. But right here, check it out. You plug in a 4, you get out a 5, and then you plug in a 4 again, and you get out a 6. That machine is broken. So that's not a function. The machine's broken. So you would say not a function. So there's going to be a couple of these super easy questions. All you got to do is understand it, that a function for each input, there's only one output, okay? If you ever plug in the same input 2 times and it gives you 2 different outputs for that one single input, then that machine's broken. That is not a function. Now there's many ways of asking you this. I could give it to you in the form of mapping from one group to another. I could give it to you in the form of coordinates or even an XY table. Check it out. So this is a question that you're going to see on the midterm exam. It says, does this table represent a function or not a function, right? Does it represent a function? So let's make this table bigger. Let's take a look at it. So I hope we remember that domain means input and your X values. Range means output and your Y values, okay? So this is kind of like an input, output, input, output, input, output, input, output. So is this a function? Well, do you ever plug in the same number 2 times and get out different answers? If that does happen, remember a function for each input, there has to be exactly one output. But right here, you plug in a 1, you get out a 4. That's like plugging in some dough and getting out a donut. But you plug in a 1 again, what are you supposed to get out again? You're supposed to get out a 4 again, but it doesn't happen. It comes out as a -4. That machine's broken. This is not a function. So is this a function? You're going to say no, but as you can see here, there's 2 no's, okay? So no, it's not a function. Why is it not? Because there's a repeated X value? That's the truth. Or is it no because there aren't any repeated Y values? That's strange, right? It's no, there is a repeated X value. See, if you plug in a number and you get out an answer, and you plug in that same number and get out a different answer, then that's not a function. So you would say no, there is a repeated X value, okay? The Y values, you don't care if the Y values repeat. You could have like 1, 0, 3, 0, 5, 0, 1, 0, right? All of those, you could have repeated Y values. That doesn't mean that it's not a function. I could even tell you what that function is, Y equals 0x, right? If you were to plug in 1 here, the output would be 0. Plug in 3 right there, the output would be 0. Plug in 5 right there, the output would be 0. Okay, so right here where it says no because there aren't any repeated Y values, that's nonsense, right? Because you could have repeated Y values and it will be a function. Okay, so when is it not a function? You would say no because there's repeated X values. And I mean, that's really not the full explanation. The full explanation is that you plugged in a 1, you got out a 4, you plugged in a 1 again, you got out something different than 4. That means that the machine's broken. That means that it's not a function. Anyway, let's jump to the next question. More on functions or just a relation. Or I'm not sure if it's a function, or they might just say function or not a function, right? And on these visual graphs, what we're going to be doing is applying a vertical line test. So I'm going to take this blue line right here, and as I run it from left to right, notice that there is no place of this first graph, number 10, there's no place that it actually touches the line at more than one place. You see there's, right there, it's at one dot only. Right here, it's at one dot only. Right here, it's at one dot only, right? Even if you go over here to the edge, it's at one dot only. So what that's saying, the vertical line test saying that for each input, there's exactly one output. So for example, at the input of 1, the output's 1. At the input of 2, the output's 0, because these are all coordinates here, right? The inputs are the x values, the outputs are the y values. At the input 3, the output, the y value is -1. At the input -5, the output's -2, okay? So this is a function. We're going to say yes. Yes, it's a function. Okay, let's move on to the next one. When we take the vertical line, as you could see, it crosses this graph at more than one location, right? You don't even have to use the blue line. You could just see the y-axis right there. The y-axis, that vertical line, crosses the graph at 1, 2, 3 values. In other words, these coordinates, just an estimate here, that's probably like 0, 4. This is probably like 0, -1. And probably like a 0, -6, right? Let's say that. So think about the machine. You plug in a 0, you get out a 4. You plug in a 0 again, you're supposed to get out a 4 again, and you don't. You get out a -1. Plug in a 0 again, you get out a -6. That machine's broken. It fails the vertical line test. So this is not a function. It's just a relation. I'm just going to put not a function. Just a relation. Let's move on to number 12 over here. And this last one, as you can see, it does pass the vertical line test. No matter where I stop the blue line, like stop right there, I have only one point of intersection. When I take this vertical blue line and wherever I move it to, it's only going to have one point. It's never going to have more than one point on the graph with my vertical line. Right here, it's only one point throughout. So this is a function right here. I hope this makes sense. This is a function. Function. It passes the vertical line test. Okay. So just remember, if any graph crosses a vertical line at more than one spot, then it's not a function. Not a function. I hope you guys understand that. Good luck. Let's move on to the next question. Man, this one's ridiculously easy. We're adding a bunch of things, and it's a bunch of x's and y's. So obviously, we need to simplify it, and you want to type in your answers with no spaces between your terms. But let's begin by combining those terms that are alike. I'm going to combine this positive x with that positive x. That's a total of 2 positive x's. And then we're going to combine this y plus another y, that's 2 y's, plus another y, that's 3 y's. That would be a positive 3y. And ladies and gentlemen, that is your answer. As you can see right here, the answer, it's 3y plus 2x or 2x plus 3y. It's better if you put it in alphabetical order, x's first before y's. So this is the best answer. Let's move on to our next question. Another simplifying problem. It says type in your answer with no spaces below. I'm just going to make this box bigger so I can show my work here. Again, we need to simplify. What does that mean? It means distributive property and combining like terms. So I am going to distribute this 8. 8 times 4 is 32. And of course, we have an x. 8 times -7, that is a -56. So we have 32x minus 56. What about this minus 2x? Just bring it right down and rewrite it right here. I want to write that minus 2x right next to the 56. So we have distributed. Distributed property is really multiplication, right? It's a distribution of multiplication. After that, on PEMDAS, after multiplying, you have division and then addition and subtraction. Obviously, there's no division. There is addition and subtraction. So let's combine the like terms. It's always distributed property first and then combine like terms. That's what simplify means. So let's combine the 32x minus 2x. That is a total of 30 x's. Bring down the minus 56, and voila, we are done. Right here, it's simply asking, what's the first step to solve this equation? Well, let's look at our options. Do we add 4 to both sides? Do we divide by 4? Do we add 10? Do we divide by negative 4? It all depends, right? What's the goal of solving any equation? Getting x by itself. But even before that, you're supposed to check and see if there's any distributive property or combining like terms, any simplification. But this equation's already simple, so we could just jump right in and try to get x by itself. So where's the x at? It's on the left side of the equal sign. It's not by itself. There's a minus 4 and there's a minus 10. Which one do we get rid of first? Obviously, x is what's important. The 4 is with the x. It's kind of important. Don't mess with that guy till the end. This number that's all by itself, get rid of that number first. So how do you get rid of something? You do the opposite. What's the opposite of minus 10? Add 10. So that's the first step. Add 10 to both sides. If you look at these options, that's the one with the green dot. That means that's the correct answer. Pretty simple, huh? Let's move on to the next one. Right here, it doesn't say what's the first step. It just says what are the steps in solving. Okay, this is a two-step equation. Again, you're first supposed to try to do distributed property and combine like terms, but there is no simplification to do. This is already a simple equation. Let's get x by itself on the left side of the equal sign. So you need to get rid of the minus 8 and also the 6. The question is, which one do you get rid of first? Once again, x is what's important. 6 is with the x. It's kind of important. That minus 8, that number that's all by itself, get rid of that number first. So how do you get rid of that minus 8? You add 8. I mean, you could even start solving it, but it's not asking you to solve. You add 8, and then you'll get 6x equals 30. And then your last step would be to divide by 6 and divide by 6, giving you your final answer, x equals 5. Now, they didn't ask us to solve it. They're asking, what are the steps? Well, the first thing would be to add 8 to both sides. 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 So it can't be this third one. It's one of the first two or the last one. And then secondly, we divided by 6. So add 8 to both sides and multiply by 6? Nope. Add 8 to both sides and divide by 6 on both sides. Yep, that's the right answer. If we check, that second one has the green dot. That's the correct answer right there. Let's move on. On this question, we have an equation that's involving fractions. Now, it's a simple equation, right? There is no distributive property, there is no combining like terms, but there are some fractions involved, and you probably want to get rid of those fractions. Especially, even if you're thinking, I want to get rid of the minus 7. Well, you'd have to add 7, and adding 7 with 2/3, you'd have 7 and 2/3, which is a mixed number, which some people don't like. So I'm just going to start getting rid of fractions. I want to get rid of both this fraction and that fraction. How do I get rid of a fraction? By multiplying everything by the denominator of the fraction that you want to get rid of, okay? And I always say, if you have different denominators, go with the biggest one, unless you could actually understand what the LCD is and multiply by the LCD, which is sometimes the biggest one. So the LCD is 9. I am going to multiply everything by 9. This times 9, the 7 times 9, and the 2/3 times 9, okay? Now, when you have a 9 on top and a 9 on the bottom, that's really a 9 divided by 9, and we know that 9 divided by 9 is 1. It eliminates. So what do I have? I have a 1x. I bring down, or not, I don't bring down, but I have a 7 times 9 here, or a negative 7 times 9. That is a negative 63. And last but not least, I could say 9 divided by 3 is 3, and then 3 times 2 is 6. Or I could say 2 times 9 is 18. I might as well go that route. 2 times 9 is 18. And then 18 divided by 3, it is 6. So the answer is 6 on this side. So we got rid of both fractions by multiplying everything by the LCD. In this case, it was 9. Okay. I want to get rid of this minus 63. In order to get rid of that minus 63, I need to do the opposite. Plus 63, plus 63. And that will give us a final answer, x equals 69. Okie dokie. We're done with that one. Let's move on. Once again, this is an expression that needs to be simplified, and we're going to use the correct order of operations. First, we look for parentheses, then we look for exponents, and then multiplication or division, whatever happens first from left to right, and then addition or subtraction, whatever happens first from left to right. So beginning with P, parentheses, we could see that there's some parentheses right here. 12 divided by 4, that is 3. Again, 12 divided by 4, that is a 3. So the smart thing to do is to get that answer and then rewrite everything. Bring down everything exactly the way it is. Anyway, We've done P for parentheses. Now we move on for E exponents, and we do have an exponent of 2. So the base is 3, the exponent's 2. That's really saying 3 to the second power, which is really saying 3 times 3. The base times itself 2 times. So 3 times 3, 3 times 3, that is 9, okay? So let me bring down everything else, the plus 15 and the divided by 3. Okay, so now what do? I've already gone through parentheses, I've already did exponents, and now either multiplication or division. Well, we have division, we don't have multiplication, so I must do division first before addition or subtraction. So I'm going to divide before adding or subtracting. So 15 divided by 3, that is 5. Bring down the 9 and the plus right in front of it, and 9 plus 5 is 14. That's your final answer for this question. As you can see, there it is, 14. Let's move on to the next question. Right here, they're asking us to evaluate the expression when x equals -2. So they're telling you that these x values, they really are -2. So I recommend rewriting the whole thing, but putting parentheses in place of the x's. There it is. And then after that, now that we replaced the x's with parentheses, everything else is exactly the same. Now I'm actually going to plug in the -2 value into those parentheses. So I have a -2 right here and a -2 right here. So let's think about this expression now. We have multiplication between the -3 and the parentheses. We have exponents. Yes, we have parentheses, but there's nothing really to do inside the parentheses. So we also have subtraction. We also have multiplication and addition. So obviously we're going to be doing exponents first. Now on PEMDAS, yes, first start with P for parentheses, then E for exponents, and then multiplication or division, and then at the very end, addition or subtraction. Okay, so again, there is parentheses, but there's nothing to do inside the parentheses, so we don't worry about that. We move on to E exponents, and as you can see, we really have a -2 in parentheses squared. That's the exponent that we're going to do. Now, -2 in parentheses, right? -2 in parentheses squared is really a -2 times a -2, which equals a +4. So what we really have here is a +4 with a -3 right in front of it. And you could keep the parentheses to remind yourself that you're multiplying, or you could put a multiplication dot. It's totally up to you. But let me rewrite everything. I have the -7 times -2 and the +5. Okay, so we have gotten rid of exponent. There was nothing to do inside parentheses. Then we did exponents. Now multiplication or division. We have multiplication here and also multiplication there. So we're going to do both of them. I want to begin with this one, -3 times 4, that's -12. And I might as well go to this next one, the -7 times -2. And notice that that's a -7, but I want to call it a -7 times -2. That'll be a +14. And last but not least, I'm going to bring down that +5. And now, at the very end, you're going to do addition or subtraction. Depends on your signs. You owe 12, you have 4. If you owe $12 and you have $14, I said 4, I'm sorry. You owe 12, you have 14. You could pay them off. You'll actually have $2 left over. So -12 plus 14, that's +2. And then you bring down the +5, and 2 plus 5 is the final answer, 7. As you can see, that answer is 7. On this question, want to evaluate this variable expression. There's two different types of letters. There's H's and G's, and they give us both values. The G value is 4 and the H value is 8. So I recommend rewriting this exactly the way it is, but with parentheses instead of the H and with parentheses instead of the G. So this is a 6H, 6 parenthesis, plus 2G, 2 parenthesis, plus 4. Okay. Now, again, the H is 8. So I'm going to take that 8 and put it right in here. So again, the H value is 8. Put that 8 right in there. The G value is 4. Put that 4 right there. Obviously, the G is 4, so you put a 4 in there. So now you ask yourself, do we have any parentheses? Yes, but there's nothing to do inside of the parentheses. Do we have any exponents? No, there's no exponents. Do we have any multiplication? Of course, we have multiplication right here and also right there. So let's do the multiplication. 6 times 8 is 48. +2 times +4 is a +8. And then we also have this +4 at the very end. Bring that down, +4. So at the very end of PEMDAS, you have the addition or subtraction. In this case, it's all addition. So let's do that. 48 plus 8, that's 56. And 56 plus 4, that is 60. The answer is 60 to this one. This one's a simple distributive property problem. Let's take that negative 11 and multiply it by 2x. Negative 11 times 2, that's negative 22. And of course we have an x right there. And then distribute it to the other one. Negative 11 times a negative 3y. A negative times a negative is a positive. 11 times 3 is 33. And of course we have a y right next to it. And ladies and gentlemen, that is our answer. Negative 22x plus 33y. Okay, always put the x term first before the y term. Always try to stay in order, in this case alphabetical order. Right? If you ever have like answers with A's, B's, and C's, put the A first, then the B, then the C. Anyway, this next one, number 28, it says to simplify, well, it doesn't say simplify, but that's what we're supposed to do. Again, PEMDAS is the correct order of operations. So P is for parentheses, and we do have parentheses here. Let's begin with 71 plus 29. That happens to be 100, okay? So 71 plus 29, that is 100. I'm going to bring everything else down, the division, the 2, and the minus and the 1. So PEMDAS, parentheses first, E for exponents. Is there any exponents? Of course not. Do we have any multiplication or division? Yes, we do. Okay. So what is 100 divided by 2? That's 50. So we have 50 minus 1. Answer is 49. Okay. Jumping to the next question. Another simplified problem where you're just combining like terms. Pretty simple to do. I have a bunch of x's and a bunch of y's. I recommend it's better to start in alphabetical order, right? Combine all the x's that you could combine. So I really have one x, one positive x right here. Notice that I'm circling the sign that's in front. That's another positive x, because that'll tell you if you have or you owe. And we also have another positive 3x's, right? So I have an x, I have another x, that's 2 x's. I have another 3 x's, that's a total of 5 x's. So I really have 5 x's. And then we move on to our y's, okay? So I have one y, I have another y, that's a total of 2 y's. I have another y, that's a total of 3 y's so far. Now, let me just point that out, that's a total of 3 y's so far, right? But then we have a negative 2y. So we're going to take away 2 y's from those 3 y's. So if I have 3 y's and I take away 2 of them, I'm only going to have one of those y's left. So that's why it's a positive 1y, or just positive y left, okay? So 5x plus y, or y plus 5x. You could even put a 1 in front of the y if you want, but there's your answer, 5x plus y. Last question of this video, solving this equation that involves fractions. So we're simply going to multiply everything by the denominator of the fraction that you want to get rid of. So if you wanted to get rid of the 2/3, you'd multiply by 3, multiply by 3, multiply by 3. Everything by 3, right? But if you are even trying to get rid of one fraction at a time, I would go with the one with the biggest denominator. Get rid of this one first because it may be your LCD. In this case, the LCD of 3 and 6, it is 6. You'll be able to cancel out all fractions by multiplying by this bigger denominator 6, which in this case happens to be the LCD. So we're going to multiply by 6, multiply by 6, multiply by 6, everything by 6. And we know that when we have 6 divided by 6, that ends up eliminating. 6 divided by 6 is 1. We have a nice beautiful x left over. And then we have minus 4 times 6, that's 24, right? 4 times 6 is 24. So what we really have is minus 24. The equal sign comes down. And over here, again, you could say 6 divided by 3 is 2, and 2 times 2 is 4. Or you could say, if you wanted to, 2 times 6, that's 12. And then 12 divided by 3, that is 4. Either way, you get a 4 on the right side of the equal sign. Let's continue solving on and get rid of the minus 24, because again, the goal is to get x by itself on the left side of the equal sign in this case. You don't want this minus 24. You get rid of it by doing the opposite, plus 24. That'll cancel out, but it'll be off balance. What you do to one side, you do to the other side to keep that balance, to keep that equality. So 4 plus 24 is 28. The equal sign comes down. The x also comes down. There's your answer, x equals 28.